Another example, in this case for list. So let's create an object LIS for list, calling the list function. And here I'm going to provide a logical vector containing two values, true and false. That's going to be the first element in the list. Let's also provide a numeric sequence from 1 to 3. And that's it. So it's going to be a super simple list in this case. If I want to get, or if I want to see what's in the first position, so again, bracket number 1, the closing bracket, what this will give me, it's going to be the vector in the first wagon, using the analogy of a train with wagons, the analogy of a list. And I'm just going to simply abbreviate it with T for true, F for false. You're going to get this guy. But again, this is the object inside our first imaginary wagon. So this is using the analogy of a list as a train. As you can imagine, well, you could do the same thing if you specify the second position, then list bracket to bracket. The output is going to be the vector in the second position. It's the numeric vector 1 to 3, but these will be contained inside its own wagon, the second wagon. So what I'm writing here in pictorial format, in terms of what you will see displayed in the screen of your console, for instance, could be something like this. For the example list and the first element, what R will display will be a set of double brackets, then position 1. This is gonna match the number specified inside the brackets. And below, you're gonna find a set of single brackets indicating the starting position of the true and the false values. And then same thing for this, what's gonna happen from the point of view of the console? Well, you're gonna have another set of brackets with the number 2 that matches the position that you are subsetting. And then below, again, because the output is a vector, the first position is gonna be 1, the second position 2, and the second position 3. So this is actually the way things are gonna be displayed on the console in R. Now, what about matrices? Again, these are two-dimensional objects. So let's create a toy matrix with the matrix function. And I'm gonna do something super simple. I'm gonna define a vector numeric sequence from 1 to 9. And I'm gonna arrange this vector into a matrix with 3 rows and 3 columns. You could actually write this command in a more simplified, more compact way. But again, just for illustration purposes, let me be super explicit and write the exact number of dimensions with their arguments end row and end col. In pictures, what do we have here? So R will create a matrix that you could picture this with a 3x3 array, and then containing the following elements 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is what our object mat will look like. There are different ways to manipulate two-dimensional objects. For example, what if you want to select the element in the second row and the second column? So in other words, what if you want to select these 5? Then all you have to do is indicate inside the brackets that you want to look at the second row, comma, the second column, and that's it. And the output of this is going to be the value 5 that we wanted to extract here, cell in the second row, second column. Another example, for instance, you could specify, instead of just a pair of single numbers, you could also specify vectors. For instance, from the first row till the second row, and then from the second column till the third column. So just momentarily, what's going to happen? I'm looking at the first and the second rows, and then I'm looking at the second and third columns. So that's gonna give us an output of a 2x2 matrix containing the 4, 5 on the first column, the 7 and 8 in the second column. What if you just want to select or subset a specific row? This is where, again, you use a pair of single brackets. So we need an indexing vector for the specific column that you want or a specific row. So let's start with a specific rows. Say I want to get everything that is in the second row. So I just have to specify 2 and then comma. For the indexing vector of the columns, I specify nothing. So I'm going to leave empty that space. And again, this will give me everything that is in the second row. So the 2, the 5, and the 8. What about if I want to specify a single column? So same idea, just type the name of the object, single brackets, nothing for the indexing vector of the rows. And let's say I want to get the third column. So in this case, the output will be the elements in the third column, which is going to be the 7, the 8, and the 9. What if you want to extract not just a single column, but let's say more than one, various columns? For instance, I want to extract the third and the first column, the third and the first column in that order. So I put everything inside a vector with the combine function. Again, I'm interested in the columns, so this is why I use the second position. And then the first indexing vector remains empty, so that in that way, I can get as the output everything that is in the third column. That'll be the 7, the 8, and the 9. That's going to be what appears in the first position, and then in the last position, column 1, that's going to be the 1, 2, and the 3. Similar to what we did with vectors, you could also take a matrix and then use negative indices. For example, I could specify -2, just one indexing vector for the rows, and this will exclude the second row. So I'm gonna obtain a matrix with the 3 columns, and then it's just going to be what happens in the first row, 1, 4, 7. We exclude the second guy, and then the third row, 3, 6, and 9. So this would be the output of matrix bracket -2 comma nothing, and then the closing bracket.